All right, so yesterday we talked about degrees, and then we talked about the Smarties, and we made circles with Smarties, and then we made other circles, and we proved that, what did we prove, Anybody remember? There's 6.28, or what did we call it yesterday too? 2 pi. There's 2 pi radians in a circle, right? Okay. So instead of 360 degrees, there's 2 pi radians in a circle. So 1 radian is the measure of the central angle theta. Okay, that symbol is called theta. Okay, that intercepts an arc S equal in length to the radius r of the circle. Okay, so what's happening? What's the haps, brah? Okay, so what's happening is you've got this arc length right here, and we'll call that S. And that arc length S is equal to the radius. Okay, it's the same distance. So if you were walking along the circle, you would walk a distance of r. Okay? What a radian is, then... Oops, I missed. Oh, way bad. What a radian is, then, is this angle here is theta. Okay? It's the angle measure that it takes you to get that arc length. Now, yesterday, I just learned to say yes. Yesterday, we were kind of guessing at how many degrees a radian was. Okay? And a radian is actually, it's 57 no, it's like 28 something. 57, let me go down just a little bit. It is 57.2958 degrees if I rounded it to 4 decimals. It is 2957795138082 degrees.
How many are we going to need to use? All of it?
None. Because we're never going to round it to that degree. The nice thing about radians is they're exact. Okay? Because we use pi in them. So let's figure out how we can convert from radians to degrees. Okay, so how many degrees is 1 radian equal? We just did that. But how many radians for a complete revolution? So this one was 57 we'll call it 3 degrees. And how many revolutions, or how many radians to get all the way around? 6.28, which we call 2 pi. Okay. All right. So how we do, okay, so it's 2 pi to go all the way around. But that's the same as what? In degrees. It's the same as 360 degrees. So 2 pi radians is the same as 360 degrees. Can I reduce that fraction? Pi over 180, right? Okay. So that is going to become pi over 180 degrees. So pi radians is going to be our conversion. Okay. Now, the alternative conversion would be 180 degrees over pi radians. Okay. We can flip that around. Okay. When we think about converting, I loves me some factor label method. those of you that have taken a scientific class have done the factor label method multiple times. Okay? So if I'm converting 6 feet into inches, okay, I would start with 6 feet, and I just put it over 1 just because that's what I do. Okay? And then I got feet. I want to get rid of feet, so 1 foot is how many inches? 12 inches. So I like that. And then my feet go away, and I'm left with my label that I desire. Or if I needed to go even further, I could go even further. You know, I could add another conversion to get it to another one, and another one to get it to another one, and so on and so forth. Okay? So this ends up being 72 inches, because then I multiply across. Okay? And I'm left with just inches. Okay? Start with 32 quarts. How many quarts are in a gallon? I think there's 4 quarts in a gallon. So that would be 4 quarts on the bottom is 1 gallon there. So my quarts go away, which is good because I want that 1 label to be there. And so when I multiply across, I get 32 over 4 gallons, which then that reduces down to 8 gallons. Okay. That factor label method is going to be useful when we're converting between whatever it is we need to convert to. Okay. So, for instance, 90 degrees, I want to convert 90 degrees into radians. Okay. So I'm going to start with 90 degrees over 1. Now I want to get rid of the degrees and leave me with radians. So my conversion is going to be 180 degrees over pi radians. My degree symbol, or my degree, the label, gets gone. It gone. Okay? And that leaves me then with 90 pi over 180. Can that fraction be reduced down to pi, right? We got pi on top yet, and 2 on the bottom, correct? And so this would then be 90 degrees is pi over 2 radians. Okay. Now, do you have to draw or write out the radians? Okay. The answer is, in this case, no. Because radian measures, I almost said radian degrees, radian measures have pi in them. Okay? We will assume that if you give an answer in terms of pi, that you're talking in radians. Okay? Now, we could also, this alternative to that is, if I said here, where's okay, hold on, I gotta clear this out. If I said pi divided by 2, and I said 1.5708, okay, then I would have to say radians, because I don't know if I'm talking about degrees or if I'm talking about radians. Okay? So if I give the decimal approximation, which, just so you are aware, Mrs. Hill and I do not like decimal approximations, we're fractions. fraction, people. Okay? Okay? Radians, usually in fractions. But occasionally, we will give them to you in the decimal. But then afterwards, it will say radians. Okay? So, what I would like you to do now is I would like you to convert those two. Please convert 350 degree or 315 degrees into radians and 210 degrees into radians. So, 315 degrees, multiply that by pi radians over 180 degrees. Gets me. So that's going to be 315 pi over 180. Well, let's see, both can be divided by 15. 21. Both can be divided by 45, right? Actually, let's go by 45. So that would be 7, right? 7 pi over 4. So I get 7 pi over 4 there. Okay? On this one, 210 degrees. Pi over 180. So that is 210 pi over 180. So that is 7 pi over 6. In terms of that one. YB? Buddy. Yeah, YB? Yeah, buddy. Thought you were going to be on your phone the whole time. Oh, look who decided to pay attention in class. Okay? Now, we can convert back the other way too. Okay? So if I've got pi over 6, and that's in radians because I see pi, anytime that you see pi, you think radians. Okay? Right? Unless it tells you otherwise. So think pi over 6. So now this is in radians. I'm going to multiply that now by pi radians over 180 degrees. And then my radians now cancel each other out. And then, so if I multiply across, then that would be 180 pi over 6 pi. What cancels out there? The pi's. Okay? And so then the pi's cancel out. 180 over 6? 30. So this one is just 30 degrees. Hi. Okay? Convert that one. Let me see what other one we got. What do we got down here? Oh yeah. Oh yeah. I like it. Okay? Convert. Actually, you know what? Yeah, convert 2. Well, I'll do 3 in a minute here. So converting number 2. So 9 pi over 2. That would be in radians. And then we're going to multiply that by pi radians and 180 degrees. So the radians cancel each other out. The pi cancels each other out. Why don't you stop yelling at me? Why don't you let me be creative? I let you be creative and be on your phone the whole class.
I like your creativity.
Whatever. 2 goes into there 90 times. So I'm going to go with around 810 degrees there.
Around? What is that? It is.
If you don't like my sparkle, get off my rainbow.
No, I like your sparkle.
So then we got these other two. So 3 here. I probably should have just put the 3 there and should have put radians on it. So I'm going to do that, and I'm going to do this if I can. I should be able to. The 2 different ways of why didn't it go up? Come on now. There. The 2 different ways of or alternative ways, I should say, of showing radians. Okay? So the first way is just putting rad after it, because it's rad, man. Okay? The other way is up where that degree circle goes, instead of putting the degree circle there, putting an R there. Okay? So we can convert these the same way that we converted the other ones. So now this is 3 radians over 1. I need to multiply that by pi radians over 180 degrees. Okay. My radians cancel each other out. Okay. And then this would just be, what is that? That's 540 over pi degrees. Okay. Now, if you would have chosen to make that be a number, then we would go 540 and we would divide it by pi, and we would go 700, and then we would do the approximate here, 171.887 degrees. Okay? Which one do you think I prefer more? A fraction. I like fractions. Yeah. Okay. So then this one, 1 radian over 1 times 180 degrees over pi radians. The radians cancel each other out. That leaves me with 180 over pi degrees, which we already said was 57.2958 degrees. Okay. Yes, ma'am.
You need to put the parentheses around it.
No, but because I just do because it's the fraction, you know, and then that way it doesn't get confused with that it's in radians because the degree symbol is controlling it.
Okay.
Okay. So, converting to and fro. There are 4 of them. I would like you to convert them to the other one, given what they're in. All right, so 11 pi over 45. So that would be 11 pi over 45 times. So now that is in what? Radians or degrees? That's in radians, right? Because we see the pi. So that means I am going to get rid of said pi and leave it in degrees. Radians cancels out. Pi cancels out. And 45 goes into 180. How many times? 8? 4? 92? 4? Okay. So you get, in the end there, you get that this is 44 degrees. Okay. Okay. 4. 4 is just 4. Is that radians or is that degrees? radians because it doesn't have the degree symbol. So that one is in radians. Gone there. So then that leaves me with, what is 180 times 4? Is that 720?
Yeah.
Approximately, how much? 720 divided by pi. Oh, tap the brakes. 229.2. Actually 183. Okay. 18 degrees. That one is in degrees. Which would be, so 180 degrees times pi radians. So the degrees cancel each other out. 18 goes into 180 10 times. So we get pi over 10 radians there. Yes, okay. 510 degrees times pi radians over 180 degrees. The degrees cancel each other out. The zeros cancel each other out. 51 can be divided by 3 17 times. 18 can be divided by 3 6 times. So that ends up being, for me, 17 pi over 6 radians. Yeah, B? Yeah, B. What we handed, or what I handed out to you on that pink sheet is the homework list for chapter 4. Sorry, the pages aren't on there, but the sections are. So section 4.1, numbers 1 through 37 odd, 44, 45, 47, 53. Should be able to do a majority of those right now. Okay. Any questions? Footballers, good luck. Soccerers, you guys got something going on this weekend? No, you're off this weekend? Okay, good win last night though. Volleyballer, good job. Way to lead the team last night. El Capitan. Okay. Am I missing anybody? Cross country, you got something going on this week?
Yeah.
What you got?
Merrill meets.
Merrill, okay, good luck. Run fast. Don't step in any holes.